Yo, what's up? It's Mr. Wagner here. Hopefully you are watching this one only if you have already watched Dr. D's video, which goes over making a Bohr model and a Lewis model for a neutral atom. Now, mine is going to be an example of making a Bohr model and a Lewis model of a charged atom. So we will not have an equal number of protons and electrons. Now, we'll get started with the Bohr model because that's a little more complex, and we'll finish with the Lewis model, which is a little simpler and also a lot more useful for our purposes. So I think it's nice to start with the number of protons because that is something that will never change for whatever element you're thinking about. And to find the number of protons, we can start by locating the element on the periodic table. Here is boron, and it won't be right next to beryllium if you look at a real periodic table, but you can still find boron, and you can see that it has an atomic number of 5. Well, the cool thing about atomic number is that it always tells us the number of protons. These are always equal. So boron will have 5 protons, which means we can go down here and we can say 5 protons. Sweet. Now we can also actually, and this is just kind of like a little side note, but it's good to think about because we will need to know a little bit about ions, especially in the second half of our project, that the total charge can be calculated by saying the number of protons minus, in this case, we are saying 6 electrons. Now you'll notice that having 6 electrons did not change our number of protons. If we're working with boron, doesn't matter how many electrons we have, we will always have these 5 protons. And one thing that is important to keep track of that you definitely don't need to add this to your slide, but it's smart to kind of think about, be thinking about these kinds of things. So we have 6 total electrons, and when we are going to add our electrons to these different shells, it's smart to remind ourselves that we start with the inside shell, the core, and then when that's full, we can fill up our valence. So a really good thing to remember is that this first shell is like a little baby shell. It can only hold 2 electrons. It's really not working with too much. And so we know that we've got 2 core electrons. Sweet. And then from there now, we can say, okay, if we have 6 total and 2 core, well, we should have 4 valence electrons. Sweet. So that's cool to get that breakdown. And it's important to notice as well that the valence shell is always just the furthest outside. Like if we had 3 shells, the first 2 would be core, and the last one, the furthest outside, would be valence. If you watched Dr. D's video, or if you didn't, he liked to refer to it as like thinking of an apple, right? Like the nucleus with the protons and the neutrons is like where you find the seeds in the very middle. And then the core shell here is like the actual apple that you would eat. And the valence shell is like the skin on that very outside. So we've added 2 electrons so far out of our 6, and we need to go ahead and add 4 more. So 1 and a 2 and a 3 and a 4. And another thing to point out is on your Bohr models, there is really no rules around where you place them in that particular orbital, in that particular shell. You just have to make sure you have the correct number of protons and electrons. Sweet. So this is our completed Bohr model, actually. And so to review a couple of main points, we changed our number of electrons. In a neutral Bohr atom, let's make a point of that. Neutral atom, you will have the same number of protons and electrons, because if it's neutral, that means it has as many positives as it does negatives. And each proton can be thought of as like a +1, and each electron can be thought of as like a -1. So that is why here they are equal. When we change our number of electrons, that does not change the number of protons, but it does mean that we are no longer neutral. And in this case, we have a -1 charge, because 6 minuses and 5 pluses would leave us with a -1. Okay, so that's the Bohr model. And now we're going to go on to the Lewis model. And we have 4 valence electrons, and that's all that we care about, because the Lewis model only valence electrons. The Lewis model is only valence. So the first step is that we're not doing element X, we're doing boron, and boron has a symbol of B. So we want to make sure that anybody that's looking at our model knows we're talking about the element boron. And now we just have to make sure that we are filling in each of our 4 zones with at least 1 electron before we make any pairs. You don't actually have to go in this exact order, 1, 2, 3, 4. The numbers are just to show that there are 4 spaces. You cannot make a pair until you've filled all 4 spaces, which means with only 4 valence electrons, we should not see any pairs here, because we have to fill 1 spot, 2 spots, 3 spots, 4 spots. Oh, this last one's a little bit. Oh my gosh. If you're having trouble with this, especially with the big letters, you can click, get this menu up, go to order, and go to send to back. That makes it a little bit easier. Oh my goodness, clicked on the minus sign. Oh my gosh. The struggle is real, you guys. Oh, there we go. Okay. All that to move it up a tiny smidge. Anyways, this is what boron would look like with a charge, because right here we can see it has 4 valence, 1, 2, 3, 4. And based on doing just a little bit of simple math, we can tell that it has a -1 charge. So this is an example of doing a Bohr model and a Lewis model when your protons and electrons are not equal. Hopefully you found this helpful. If you watched this video without watching Dr. D's, I would recommend that you go back and watch his as well, because his video is an example of doing it with neutral atoms. Anyways, if you have questions still, you know where to reach us. Let's see, you know what? In fact, I don't want to duplicate it. No, go back. Check this out. Jay Wagner at summitps.org. Edias at summitps.org. There we go, y'all. That's all you got to do.